Hi guys, welcome to EEEPoint. So this is the second lecture of the basic electrical engineering series, and the topic of today's lecture is Coulomb's law and electric field. Before getting started with the lecture, I would like to request you all to subscribe to this channel and turn on notification so that you don't miss any future videos. So let's start with the Coulomb's first law. So Coulomb's first law basically states that two charged particles of the same charge will repel each other and two charged particles of the opposite charge will attract each other. So as you can see, in the first case both the charges are of positively charged and the force acting between them is outwards in the direction of the arrow, and in the second case both the particles are of opposite charge and they are attracting each other towards their direction, so the arrow is inwards. This is basically similar with the law of gravitation provided by Newton. Now let's talk about Coulomb's second law. So Coulomb's second law basically gives us the idea about the magnitude of the force that will be acting between charges. It states that the magnitude of the force acting between two charges is proportional to the product of magnitude of the charges. So if charge 1 is of magnitude q1 and charge 2 is of magnitude q2, the force will be proportional to q1 times q2. And it also states that the magnitude of the force acting between the charges will be proportional to the inverse of square of distance between charges. So suppose the distance between these two charges are r, then the force will be inversely proportional to r square, or will be directly proportional to 1 by r square, whichever you want you can say. So let's talk about some mathematical expressions of this Coulomb's law. So the force acting between two charges q1 and q2 is proportional to q1 times q2, and it is also proportional to 1 by r square. So if we combine these two with the help of a proportionality constant, we will get F equal to k times q1 q2 by r square, where this k is the proportionality constant and its value is given by 1 by 4 pi epsilon. So this epsilon is basically constant for a certain medium, and it is called permittivity of the medium. And epsilon in vacuum is generally expressed as epsilon naught, and the value of permittivity in vacuum is given by 8.854 into 10 to the power minus 12 farad per meter. We'll talk about this epsilon and permittivity in very details in our electromagnetic lectures. So now let's talk about electric field. So electric field is basically a vector quantity and it exists at every point in space. So it doesn't matter wherever you are, there is some electric field present. But when a unit charge is, or rather a unit charge is placed in electric field, it will experience some force. This force that a unit positive charge experiences in some certain electric field is called the electric field. So let me repeat it once again. There is electric field present everywhere, and the magnitude of this electric field is defined by the force that an positive unit charge will experience in that electric field. So suppose there is electric field and you place a positively charged unit charge in that electric field, it will surely experience some force due to that electric field, and the force that the 1 Coulomb charge or unit charge experiences is rather given as the magnitude of that electric field. So electric field can be expressed in terms of force. F equals to Q times C, where F is the force between the charges and Q is the magnitude of the charges and E is the electric field itself. So we can rather write E equal to F by Q. So electric field is given by force experienced by the charge divided by magnitude of the charge, and the unit of this electric field is given by Newton per Coulomb because it is force per charge. So guys, that's about the electric field, and we'll talk about current and voltages in the next video. So guys, thank you for watching, and if you're new here, please consider subscribing because it encourages us to make more videos like this. So